We're talking about Descartes' rule of signs. This is something that what I didn't learn as a teacher. It's not a trick I learned as a student, and it would have made life a lot easier as a student. This narrows down your possibilities, and when we're trying to find out when it crosses the x-axis, when the roots are, or where the zeros are, it helps us narrow down a way to identify the numbers quicker. Because you're going to end up with a long list of numbers to test, and this narrows it down to where you may be able to knock out all negatives, or you may be able to knock out all positives sometimes. And that way you only have to test the negative or the positive numbers. Or it may give you that there's only going to be one positive, so after you get that one positive, you stop testing any more positive numbers. And so it's basically eliminating out number choices for further when we go into these division problems next week. Okay. And I may not be saying his name right. Again, I learned this out of reading a book. So I call him Descartes. And he has a famous quote that we're going to learn about today in your homework. But the rule of signs, and I'll read through this problem for you for those that are in the back. You have 4x to the 4x to the 7th plus 6x to the 6th plus x to the 5th.
Plus 3x.
Oh, missed the 3. Okay, let me start over. 4x to the 7th plus 3x to the 6th plus x to the 5th plus 2x to the 4th minus x cubed plus 9x squared plus x plus 1 equals 0. So, when we were dealing with the bounce, wiggle, cross notes from last week, it was in factored form. This is an expanded form. This is where it's been all multiplied out. When it was in factored form, you found the degree by adding the exponents. When it's in expanded form, you take and you look and you go, okay, what's my largest number? 7. So my degree is 7. So when there are no more parentheses in the problem, how do we find our degree?
The highest number.
Highest exponent. So this is a 7th degree polynomial. That means there is at max 7 times it will cross the x-axis. Because you remember how sometimes it would touch and it would do had 4 or 5 at the same spot? That may be the case. We're going to be adding in imaginary roots and identifying the number for imaginary roots this week. Imaginary roots will not actually cross the x-axis ever. They're when you see a turn up in the middle of the quadrant 1 or quadrant 2 or down in quadrant 3 or 4. So, this is a scary sounding rule, but I want you to help me by identifying something. We're going to go through and underline and orange all the ones that are negative or a minus sign in front. And we're going to underline in blue everything that is positive or a plus sign in front.
Can we do different colors?
Yeah. So we changed from positive to negative and from negative to positive. So how many sign changes did I have?
3 or
2. That will be your different color to make those little arrows.
Oh crap, I did that in pencil.
Or you can do it in pencil.
We all did the same thing.
Okay. There is a theorem in algebra that says that if you have imaginary roots and there's not an imaginary number in the original problem, that all imaginary roots need to be in pairs. So that means that you have the conjugate pairs. Remember when we multiplied those for the last test? We're going to have conjugate pairs in our imaginary roots. Same thing goes for irrational roots. That's the square root roots. They're going to have conjugate pairs. And so we're going to be using the 2's to help us narrow things down because of the imaginary possible roots. And so there are 2 or 0 possible positive roots. And the reason I counted down is because I was talking about, as I was just talking about, with the imaginary roots as a possibility, we want to count down by 2's.
Is that
Possible positive roots. Oh, and that, let me move that 2.
possible?
Okay. So our possible positive roots are determined by the sign changes of the original problem. Our possible negative roots, on the other hand, are based upon plugging in a negative x for every x. So we're going to do 4 times negative x to the 7th plus 3 times negative x to the 6th plus negative x. And you notice how every time I'm putting this negative x in here, I'm putting it in parentheses. To the 5th plus 2 times negative x to the 4th minus negative x to the 3rd plus 9 times negative x to the 2nd plus a negative x plus 1 equals 0. So all I did is plugged into every single x a negative. And we're going to go back through and figure out what it did to the signs in front. So, if I have negative x times itself 7 times, is the answer going to be positive or negative? So a negative is going to change the sign in front. So that's going to make it a negative 4x to the 7th. If I have negative x times itself 6 times, is that going to make it positive or negative?
Yeah.
Positive, because if you multiply an even number of negatives,
Yeah.
it makes it a positive. So that's going to keep the sign the same. And so basically what's happening is we're going to be affecting the sign in front of each term by plugging in that negative. So a negative x to the 5th power. Is it going to keep the sign or change the sign? Change it. Because it makes it negative. If it's negative, it's going to change the sign. So negative x to the 4th power. Keep it or change it? Keep it. Negative x to the 3rd power. Keep it or change it? Change it because it becomes negative. Negative x squared. Keep it or change it? Negative times a negative makes a positive, so positive doesn't change the sign. So we keep it. And negative x to the 1st power means we have a negative, and so we're going to change it. And that 1 doesn't have any x's involved with it, so we just write down a 1. Now let's get our colors back out. We are going to underline in blue. I'm doing blue for all my positives. And orange for all my negatives. And then count your sign changes. What did I miss?
Doesn't it go from the negative x?
Negative x.
Yeah.
Oh, I missed the one. Yeah. I thought I had 5 originally, and I was trying to figure out where I lost one. Okay, so that means, and because we plugged in a negative, we're going to do negative. So 5, we're going to count down by 2s. What's the next number?
3.
Or 1
Wait, what is
possible
this? Oh, okay.
negative.
Where did you get 3 and 1 from?
You always count down by 2s. So we start off at 5 from the number of changes we identified. And you count down by 2. And it always is going to be counting down by 2. So what's the number next? If I subtract 2 from 5, I end up with 3. I subtract 2 from 3 and I end up with 1.
So this goes for both positive and negative.
And imaginary.
And 0 counts for the.
Why did you change from positive to negative?
Because we're looking at the sign changes. We're trying to find out all the possible positive roots and all the possible negative roots. And so here, that's when we plugged in the negative for the x, or negative x, and saw how it affected the sign. And so, since there were 5 changes of signs in the negative, that's just when we started with 5. When we had it in as positive x, we had 2 changes of signs, so we started off at 2 and count down by 2. So you're always going to count down by 2. And it goes back to the fact that the imaginary roots have to have conjugate pairs. Because the last thing we're going to identify is our possible imaginary roots. So I'm just going to sum it up. We had 2 or 0 possible positive roots. We had 5, 3, or 1 possible negative roots. And so for this, what this means to me, whenever I'm testing my numbers, which is what we all be looking into next week, that means there's definitely a negative root. So what would I start with? My negative numbers. Because I know there's going to be a negative root. Does that make sense? And once I have that negative root identified, then I can go into my pot to whatever I want to from there. And that helps me narrow down to where I'm not wasting my time looking through all the positive ones when there could be a 0 for that. Not always does it narrow it down for you, but it does help quite frequently. Now, let's look at the imaginary. So let's figure out our possible imaginary roots. This goes back to your degree for your polynomial. So, for our degree, what do we have for a degree? We had a 7th degree. Can we have an odd number? Because remember I talked about we had them in pairs. Can we have an odd number of roots if they must have a partner? No. And it has to be, it can't be more than 7. So what's the number just short of 7? 6. 6, 4, 2, or 0. Possible imaginary roots. So, there are 2 ways to think about this. If you'd like to count down, you just drop down to the even number right underneath it and start counting from there. If you don't mind counting up, start from 0 until you reach your max. And that's how you work on the imaginary. The imaginary is another one where you're not having to do any math. You just have to take a look at what the number is. We're going to do 2 more of these just to get practice, and then I'll let y'all work on the assignment. They are not going to be as long because I wanted to do the more complex, the first one. So, step 1, identify your positives and negatives. And our problem here for number 2 is x cubed plus x squared minus x minus 1 equals 0. I'm underlining in orange all my negatives and in blue all my positives. And then counting your changes. So how many possible positive roots could I end up with here? 1. Can I count down by 2s from there? That means I definitely have 1 positive root. So you test all your positive roots, and you are going to find one of them that is a positive root as an answer. Okay, next step is to plug in a negative x into every x. And eventually you're going to see a pattern of what you're doing to the signs. And you may not actually have to show the step of plugging it in. You can go through and change your signs according to the pattern. So if it was a negative x cubed, is it going to keep the original sign or change it? Change it. So it's now a negative x cubed. If it was originally a negative x squared, is it going to keep or change the sign? Keep it. If it's a negative x, is it going to keep it or change it? And the negative 1, keep. So go through and identify your signs and count your sign changes. So how many possible negative roots did I end up with?
2.
Or 0. So you count down from the 2. And so what was our degree in this problem?
3.
So we had a 3rd degree. And so that means that my imaginary is 1 less than that, 2 or 0 possible imaginary roots.
You always do a number less than the degree?
No, you always do it to the even number either at or below.
So if it was a 4, you just do 2. It would still be 2 and 0.
It's going to be 4,
2,
2, 0.
Okay.
So you
so
can't.
as long as it's an even number, but it can't be above the degree.
It can't be above the degree.
So you can't do like 4 if it's at 3.
Yeah, you can't go up, but you have to stay.
So if it's at 4, it can be 4?
It can be 4. They can all be imaginary.
So if it's at 0, it can be negative.
So if it's at 4, it can be 4, 2, 0.
Okay, so we're going to do a 4 one, just so we can see an even set. And this last one, we have 2x to the 4th minus x cubed plus x squared minus x to the 5th, minus 5x plus 3 equals 0. Go through and identify your sign changes. So we had 4, because that was our number of degree sign changes, 2 or 0 possible positive roots. How do we identify our possible negative roots?
Every x to a negative x.
Change every x to a negative x. So 2 times negative x to the 4th minus negative x cubed plus 4 times negative x squared minus 5 times negative x plus 3 equals 0. So all we've done is replaced every x with a negative x. And so when we have a negative x to the 4th power, does it change the original sign in front? No. If we have a negative x cubed, does it change the original sign in front? Yes. When we have a negative x squared, does it change the original sign in front? No. When you have a negative x to the 1st power, does it change the original sign in front? And so it changes because it's an odd power, excuse me.
Because what is?
The exponent's odd.
Oh, yes.
So we're looking at the exponents. And when the exponent's even, it doesn't change it. When it's odd, it does. And the 3 doesn't have an x on it.
So even changes, odd doesn't?
Even
Even
doesn't, odd does. So identify all your positives and negative. So we end up in this case because there's no sign changes, 0 possible negative roots. And when we sum this up, we had identify how many possible imaginary roots we'll end up with.
0.
So what was our degree?
4.
So we had a 4th degree. So we want to figure out our possible imaginary roots. And so if we had a 4th degree, what number are we going to start with? 4. And count down. And that's it.